Imagine standing at the edge of a harbor. The water is calm, blue, and ancient. The sun over Sicily burns like a coin pressed into the sky. Behind you, a city 2,000 years old breathes and hums with life. And somewhere inside it, in a house with dusty floors and sand-covered walls, a man is drawing circles. He is not drawing plans for battle. He is not composing poetry. He is not praying. He is drawing circles in the sand, and he has forgotten to eat. He has forgotten, it is said, that he even has a body. That man would later be called the greatest mathematician of antiquity. Some historians believe he was the greatest mathematical mind in all of human history. But here is the thing that no one talks about, the thing that changes everything you think you know about him, and we will get to it before this is over. Because what history tells us about Archimedes is, in many ways, a story about what we choose to remember and what we choose to forget. Stay with me. His name was Archimedes of Syracuse. He lived in a time when the world was being rewritten, when kingdoms fell and rose in a single generation, when a single idea could outlast an empire. And yet, despite all of it, despite the wars and the politics and the brutal machinery of history, this one man sat down and thought deeply, relentlessly, almost supernaturally. If you are new to this channel, welcome to Numbers and Narratives by Blesswright. This is where we take the stories behind the greatest minds in history and bring them back to life. If this is the kind of content that stirs something in you, that makes you feel both small and inspired all at once, please subscribe and leave a like. It helps more people find these stories. And trust me, by the time we reach the end of this one, you will understand why Archimedes is not just a chapter in a textbook. He is a mirror, he is a warning, and he is a revelation. Now, let us go back. It is the 3rd century before the Common Era. The ancient world is not a quiet place. Alexander the Great has already swept across 3 continents, stitching the Greek language and Greek thought into the fabric of lands as far as present-day Afghanistan. His generals, the Diadochi, have carved his empire into competing kingdoms, each one clawing for power and permanence. Rome, still a republic, is growing, slowly, hungrily. The Mediterranean is not a sea. It is an arena. Into this world, on the island of Sicily, in the city of Syracuse, a child is born. The year is approximately 287 BCE, though ancient sources give us only a rough estimate. Syracuse, in this era, is one of the most important Greek cities in the Western Mediterranean, a place of wealth, culture, political intrigue, and art. Its harbor is one of the great architectural marvels of the age. Its streets are full of traders, soldiers, philosophers, and priests. It is not Athens, but it is not nothing. It is alive. Archimedes was born into a family with ties to intellectual life. Ancient sources, including the Roman biographer Plutarch and the mathematical writer Pappus of Alexandria, suggest that his father was an astronomer named Phidias. We do not know much about Phidias. We do not know his face, his politics, or his temperament. But we know what it means to grow up in a household where the sky is studied and the stars are named. It means that questions are not discouraged. It means that wonder is a legitimate occupation. We do not know the exact shape of Archimedes' childhood. History, as it so often does with great figures, leaves the early years in shadow. But we do know that at some point, he traveled. He traveled to Alexandria in Egypt, the intellectual capital of the ancient world, home to the great library, to the museum, to the finest mathematical minds of the era. It was there, on the banks of the Nile, that Archimedes encountered the work of Euclid, the ordered architecture of geometry, the language of proof. He did not merely study it, he internalized it, he breathed it, and then he took it apart and rebuilt it into something the world had never seen. Alexandria gave Archimedes the tools, but Syracuse gave him the purpose. When he returned to his city, he carried with him a mathematical fire that would burn for the rest of his life. He also carried friendships, correspondences with scholars like Conon of Samos and, later, Eratosthenes of Cyrene. the man who calculated the circumference of the earth. These were Archimedes' peers, his intellectual companions, in a world where true peers were rare and precious as gold. But even among these brilliant men, Archimedes was different, not louder or more ambitious. Different in a quieter, more disturbing way. He was absorbed, not occasionally, always. There are accounts, written centuries after his life, but drawing on earlier traditions, that describe a man so consumed by mathematical thought that he would forget to eat for days, that he would draw diagrams in the ashes of a fire, in the oil rubbed on his skin, in the dust of the earth, that servants had to physically carry him to the bath, and that even in the bath he continued to draw figures on the surface of whatever he could touch. Whether these details are precisely true or embellished by admiring tradition, they speak to something real, the portrait of a mind for whom thinking was not an activity, it was existence. This kind of obsession is not comfortable. It is not charming in person. It is alienating. The people around a mind like this often feel like furniture, present, noted, and then forgotten. Archimedes is not a warm figure in the historical record. He is not described as a great teacher, a gentle mentor, a beloved husband. He is described as brilliant, as focused, as almost terrifyingly singular. There is a loneliness in that picture, even if it was a loneliness he chose, or perhaps a loneliness he was too deep in thought to notice. And yet, what came out of that solitude was extraordinary. Let us talk about the mathematics, because this is where the word genius begins to feel inadequate. Archimedes worked in a world without algebra, without calculus, without the symbolic notation we now take for granted. He had geometry, arithmetic, and pure reasoning. And with those tools, he did things that would not be formally repeated or surpassed for nearly 2,000 years. Take the question of pi, the ratio of a circle's circumference to its diameter. Every civilization that built round things needed to approximate this number. The Egyptians had their version. The Babylonians had theirs. But Archimedes approached it differently. He did not guess. He reasoned. By inscribing and circumscribing polygons inside and outside a circle, and increasing the number of sides until the polygon pressed ever closer to the circle's true edge, he was able to establish that pi lies between 3 and 10/7 and 3 and 1/7. In modern decimal terms, between 3.1408 and 3.1429. The actual value of pi is approximately 3.14159. Archimedes had cornered it from both sides with geometric proof. Not measurement, not estimation, proof. Think about that. Without a calculator, without modern notation, using only his mind and the principles of geometry, he reached a conclusion that is correct to within a fraction of a percentage point, and more importantly, he proved the bounds. He did not say, "I think pi is approximately this." He said, "Pi cannot be less than this, and it cannot be greater than that, and here is why." That is science. That is mathematics at its highest. He did the same kind of work with volumes and areas. He calculated the area of a parabolic section using a method that was, in everything but name, an early form of integral calculus, the mathematics that Isaac Newton and Gottfried Leibniz would not formalize until the 17th century. He calculated the surface area and volume of a sphere, and he was so proud of this result that, according to the Roman writer Cicero, he requested that a sphere inscribed inside a cylinder be carved on his tomb. The ratio he had found that a sphere has 2/3 the volume and surface area of its circumscribed cylinder was to him not just a number. It was a truth of the universe, and he wanted it to follow him into death. He also worked on what he called the method, a technique he described in a letter to Eratosthenes, which was thought lost for over 2,000 years until a remarkable discovery in the early 20th century. In this letter, Archimedes described a kind of mechanical reasoning using the concept of balance and lever to intuit mathematical relationships before formally proving them. It was, in essence, a private scaffolding for genius. a way of finding truths before he could fully justify them. The fact that this document was almost lost to history is not just an academic footnote. It is a kind of tragedy we will return to. But Archimedes did not live only in the mind. He was also an engineer, and the bridge between his mathematics and his engineering was a concept so fundamental that most of us take it entirely for granted. The lever. Archimedes did not invent the lever. Human beings had been using levers for thousands of years before him. But he was the first to theorize it, to explain in mathematical terms why it works, what the relationship is between force, distance, and fulcrum, and what the implications of that relationship are. His statement on the matter has echoed across centuries. He reportedly said, and this account comes from Pappus of Alexandria, writing centuries later, something to the effect of, "Give me a place to stand and a lever long enough, and I will move the world." It was not bragging. It was mathematics. And it was true. If you could stand outside the world and had a lever long enough and a fulcrum fixed in space, the geometry of mechanical advantage would, in principle, allow any force, however small, to lift any weight, however great. Archimedes had not invented the lever. He had understood it. And understanding, in his hands, was more powerful than invention. He also designed the Archimedean screw, a helical device housed in a tube that, when rotated, lifts water from a lower level to a higher one. This device, attributed to him by multiple ancient sources, including Diodorus Siculus, was used in his own time for irrigation and for bilging water from ships. Remarkably, versions of the Archimedean screw are still used today in water treatment plants and agricultural systems around the world. A machine designed roughly 2,250 years ago is still in operation. That is the measure of a design that begins not with intuition but with principle. And there was his work on buoyancy. This is where the legend of the bath comes in, the famous story that Archimedes, while lowering himself into a full bath, noticed that the water level rose and suddenly understood that a body immersed in a fluid displaces a volume of fluid equal to its own volume. That he leapt from the bath and ran through the streets of Syracuse shouting, "Eureka, I have found it," without clothing, in full view of his neighbors. Is this story true? The honest answer is, we do not know. The story is reported by the Roman architect Vitruvius, writing perhaps a century and a half after Archimedes' death, and it is not corroborated by earlier sources. It may be legend. It may be embellishment. What is historically verifiable is the result. The principle now known as Archimedes' principle, which states that any body immersed in a fluid experiences an upward buoyant force equal to the weight of the fluid it displaces. This principle explains why ships float, why hot air balloons rise, why your body feels lighter in water. It is one of the foundational principles of fluid mechanics, and it was worked out in the 3rd century BCE by a man in a city on an island in the Mediterranean. What is also historically supported is the context of the problem Archimedes was supposedly solving, whether a goldsmith had fraudulently alloyed a crown with silver instead of making it of pure gold as commissioned by the king. Whether the bath story is literally true or a later dramatization, the underlying principle stands. Archimedes found a way to determine the density of an irregular object without melting it. The physics was real. The methodology was real. The story may be a beautiful frame around a genuine portrait. Now we must slow down, because we are approaching the part of the story that most people have heard only in outline, and almost never with the depth it deserves. It is approximately 214 BCE. Archimedes is old. He is, if the traditional birth year of 287 is correct, somewhere around 73 years old. He has lived a long life by ancient standards. He has survived the political turmoils of Syracuse, the shifting alliances of the Mediterranean world, the reigns of multiple rulers. The man who had corresponded with the finest minds of his age has now outlived many of them. Conon of Samos is gone. The library debates that once stretched across generations of correspondence have grown quieter. And yet Archimedes, it seems, has never stopped thinking. but the world will not leave him to his thoughts. Not anymore. Rome is at war. More precisely, Rome is at war with Carthage, the second of the three great Punic Wars, and Syracuse, after the death of its longtime ruler Hiero II, has made the catastrophic political decision to ally with Carthage. The decision is made by young Hieronymus, the grandson of Hiero, a ruler described by ancient sources as erratic and unwise. He is assassinated almost immediately, but the die is cast. Syracuse is now, in the eyes of Rome, an enemy. In 214 BCE, a Roman fleet and army under the general Marcus Claudius Marcellus arrive at the walls of Syracuse. The fleet is large and powerful. The army is experienced and well supplied. Marcellus is no fool. He is one of the finest military commanders Rome has produced in a generation. He expects to take the city quickly. What he finds instead is something he does not expect. Something, by most accounts, he has never encountered. He finds that the city fights back in ways that should not be possible. According to ancient sources, primarily the historian Polybius, writing within living memory of those who witnessed the siege, and later Plutarch and Livy, the defense of Syracuse was in significant part organized around machines of Archimedes' design. The accounts describe catapults of varying range, calibrated to throw stones at different distances so that approaching troops could be met with fire at any point along their advance. They describe artillery systems mounted in the walls that could reach attackers both near and far. They describe great cranes, what Plutarch calls iron hands, or grappling devices that extended from the walls, hooked onto the prows of Roman ships, lifted them partially out of the water, and then released them, causing them to crash and sink. Whether this last device worked precisely as described is debated by historians. The mechanics are plausible, though the accounts may be dramatized, but the core picture is consistent. The defenses of Syracuse were mechanical, systematic, and devastating. Marcellus, according to Plutarch, reportedly joked in bitter frustration about fighting what amounted to a one-man war that Archimedes was using his ships as buckets to draw water, toying with his fleet, and driving his engineers to despair. Whether or not this is exactly what Marcellus said, the account preserves something historically meaningful. The Roman forces were genuinely stalled. A siege that was expected to conclude in days stretched into months, then into years. There is a phrase from Plutarch that has haunted this story for centuries. He writes that Archimedes regarded his military work as beneath him, that the machines he designed were merely a sideline, a concession to the practical needs of his king, and that he considered his true work to be pure mathematics, that he looked down on engineering as a craftsman's occupation, not a philosopher's. Plutarch was writing 4 centuries after the events he described, so we must hold this account with care. But there is something consistent about it with everything else we know. A man who found mathematical truth more compelling than any application of it, who built war machines with the same indifference with which he might have brushed sand off a diagram. Not callousness, abstraction. And then came the end. In 212 BCE, after a siege lasting roughly 2 years, Rome finally broke through. Whether through betrayal from within the city or simply through finding a weakness in the defenses, accounts vary. The city of Syracuse fell. Marcellus gave orders, according to both Polybius and Plutarch, that Archimedes was not to be harmed. The general knew what he had. He wanted the old man alive. What happened next is one of the most debated and most poignant moments in the history of science. Archimedes was killed. The exact circumstances are disputed. Ancient sources give us several versions. One version, reported by Plutarch among others, says that a Roman soldier found Archimedes drawing figures in the sand, unaware or indifferent to the chaos of the fallen city around him. The soldier ordered him to come. Archimedes refused, or asked to be allowed to finish his proof. The soldier killed him. Another version says he was carrying mathematical instruments, and a soldier thought he carried gold. A third says he was simply found and murdered in the confusion, without any dramatic exchange at all. History does not give us certainty here. What history does give us is the aftermath. Marcellus, by all accounts, was genuinely grieved. He arranged a proper burial. He reportedly honored Archimedes' family. He had wanted the man alive, and someone had taken that from him. As for the famous last words, "Do not disturb my circles," this phrase, attributed to Archimedes in the moment of his death, appears in various forms in ancient accounts. It may be legend. It may be a later dramatization of the soldier story, but it has endured for a reason. Whether or not Archimedes literally said it, it feels true. It feels true to the portrait every source paints, a man more present in his geometry than in his world, more alive inside a circle drawn in sand than in the burning city that surrounded him. And now we reach it. The thing I promised you at the beginning. The thing history gets wrong, or rather, the thing history has never fully said. We remember Archimedes as a genius. We celebrate his pi, his levers, his buoyancy principle, his war machines. We quote him in physics textbooks and engineering courses. We say his name with reverence, and rightly so. But here is what we miss. Here is what the accumulation of the facts, arranged end to end, actually tells us. Archimedes did not want to be remembered for any of that. This is not speculation. His own writings make it explicit. In the texts that have survived, particularly his letter to Eratosthenes, known as the Method, which was discovered in 1,906 inches, a palimpsest manuscript in Constantinople, and which scholars have called one of the most significant mathematical rediscoveries in modern history, Archimedes describes his mathematical work not as something to be applied, not as a toolkit for war or engineering or practical life. He describes it as something closer to beauty, as the pursuit of what is necessarily true, as the uncovering of relationships that exist independent of human need or human power. He built the war machines because his king asked him to. He derived the buoyancy principle because a king presented him a problem. But what he chose to write about, what he chose to send to his colleagues, what he asked to be carved on his tomb was the sphere, the circle, the relationship between a cone and a cylinder, abstract forms, pure shapes, truths that do not depend on whether Syracuse stands or falls. He was not a warrior who happened to be good at math. He was not an engineer who thought deeply. He was a mathematician, perhaps the purest the ancient world produced, who was pressed by circumstance into becoming useful to the world he lived in. And he complied, and those applications saved his city for 2 years. And then the city fell anyway. The machines failed, the walls broke, the city burned, but the circles remained. That is the tragedy and the triumph at the heart of this story. Not that Archimedes died, not even that he died over a diagram, but that the things he most cared about, the truths he spent his life uncovering, the proofs he wrote in letters to colleagues, the mathematical structures he believed were immortal very nearly did not survive either. The palimpsest, the manuscript discovered in 1906, was a prayer book. A medieval monk had scraped the original parchment clean, erased the text of Archimedes, and written prayers over it. For nearly 1,000 years, one of the most important mathematical documents in human history was hiding underneath the words of a liturgy. It was only through the painstaking work of scholars using ultraviolet light and, later, X-ray fluorescence imaging that the original text was recovered. The Method, his most personal mathematical work, the one that showed how he thought before he proved, had nearly been lost forever. Nearly, but not quite. And that word nearly is worth sitting with for a moment, because Archimedes spent his life working on truths he believed were permanent. That a sphere inscribed in a cylinder has 2/3 its volume and surface area. That pi is between these two values and cannot be otherwise. That a lever of sufficient length, given a fulcrum, can move any weight. These are not opinions. They are not cultural artifacts. They are true, and they will be true 10,000 years from now, on planets we have not yet visited, in civilizations that have never heard of Syracuse. He was right. The truths survived. Even when the text nearly didn't, There is something in that which speaks to us across 23 centuries, across the ruins of Syracuse, across the erased pages of a medieval prayer book about what it means to pursue something that is real, not useful, not powerful, not politically valuable. Real. We live in a world that rewards application, that celebrates what can be built, sold, deployed, and scaled. We measure minds by what they produce, not by what they understand. Archimedes, in a different world, at a different time, with a different king making different demands, might have spent his entire life in pure mathematics and never designed a single catapult. We might never have heard of him, and yet the truths he found would still be true. The circles would still hold. That is what we take from him, not the levers, though the levers matter. Not the buoyancy principle, though it carries every ship that has ever floated. Not even the war machines, though they held Rome at bay for 2 years and became the stuff of legend. What we take from Archimedes is the image of a mind so committed to understanding, so stubbornly, almost religiously committed to truth for its own sake, that even a Roman sword could not make him look up from his diagram. He moved the world without touching it, not through force, not through conquest, not through wealth or status or war. He moved it by understanding it so deeply that no one who came after him could look at a lever or a circle or a floating ship without standing, in some way, in his shadow. And that 23 centuries later is still happening. Right now. The engineers who designed the ship that carries cargo across the Atlantic understand Archimedes' buoyancy principle. The mathematicians who model fluid dynamics are working in a tradition he helped found. The physicists who study mechanical advantage are, in a very real sense, his intellectual descendants. The satellites that orbit the Earth use calculations that descend through Newton, through the calculus he almost invented, through the geometry he perfected, from the man who drew circles in the sand of Syracuse. He never left his island. He never commanded an army. He never ruled a city or built an empire. He sat, and he thought, and he wrote letters to his friends, and he drew diagrams, and he died over one of them, and the world moved. If this story stirred something in you, if Archimedes, the real one, the obsessed and solitary and brilliant and human one, made you feel something, please share this with someone who needs to hear it. Subscribe to Numbers and Narratives by Blessright if you have not already. Every video on this channel is built the same way, not to impress you with facts, but to remind you that behind every great idea is a person complicated, imperfect, often misunderstood, who chose to believe that truth was worth pursuing, even when the world was burning around them. We will see you in the next story.